right, so we might need a couple of pages for this practice problem. So let's start with just a direct substitution. So we're looking at the limit as x approaches 0 from the right side of 7x raised to the sine of 8x. And when we substitute 0 in for x, we'll get 0 raised to the 0 power. So we want to manipulate this so that we can use L'Hopital's rule, but we can only use L'Hopital's rule for 0 over 0 or infinity over infinity. So we're going to use rules of logs. We know that if we have a base raised to a power, that we can rewrite this as e raised to the natural log of a to the b power. And then again, using rules of logs, this is e raised to the b ln of a. That's an ln. Let's make that a little nicer. So we're going to use that idea for this problem. So we're going to rewrite this as the limit as x approaches 0 from the right side of e to the ln of 7x raised to the sine of 8x. And then I'm going to use that rule where I can drop the power down in front, and we'll have the limit as x approaches 0 of e to the sine 8x ln of 7x. Now because e is a continuous function, I can pass the limit through this, and this is really the same as e raised to the limit as x approaches 0 from the right side of sine of 8x ln of 7x. So my focus is this exponent. So there's a notation where we can write e raised to something as an exp out in front. So we can write as exp, and then we have the limit as x approaches 0 to the right of sine of 8x ln of 7x. So now looking at this limit, when I substitute in 0 for x, I'm going to get 0 times negative infinity. So I still don't have my indeterminate form of 0 over 0 or infinity over infinity. So let's manipulate this sine of 8x to be 1 over that and put it in the denominator. So coming back up here, I have this exponent. We have the limit as x approaches 0 from the right side. We're going to leave the natural log in the numerator, and in the denominator, we're going to write this as 1 over sine of 8x. So we have that. So now, when I do the direct substitution with this limit, the natural log of 0 as it approaches from the right side is going to be negative infinity. And then I'll have a 1 over 0 in the denominator, giving me that infinity over infinity form. So I can use L'Hopital's rule. We could rewrite 1 over sine as cosecant of 8x, but I'm going to leave it like this. It's completely up to you. I like keeping things in terms of sines and cosines. And because I am going to take the derivative, I'm going to rewrite this as sine of 8x to the negative 1 power. And that'll give me a couple of chain rules, but I like that better than working with cosecant. Again, it's completely up to you. All right, so the derivative of the numerator. The derivative of natural log is 1 over the argument, so 1 over 7x, and then the derivative of the inside is 7. Now the derivative of the denominator, I'm going to drop that 1 down in front, decrease the power by 1, take the derivative of the sine, which is cosine of 8x, and then also the derivative of the far interior, which is the derivative of 8x, which is 8. And so I've got this funky thing, which is 1 over x, and then, negative 8 cosine of 8x over sine squared of 8x. So if I put 0 in here, I am still going to have infinity over infinity. Let's clean this up a little bit. I have a complex fraction, so I'm going to multiply by the reciprocal and at least get that so we just have one fraction. So I'll have 1 over x times sine squared of 8x, I'm just in a parenthesis right there, over negative 8 cosine of 8x. So this will give me the limit as x goes to 0 from the right side of sine squared of 8x over negative 8x cosine of 8x. But when I substitute in 0 for this, I still have 0 over 0. So I'm going to apply L'Hopital's rule a second time. So I'm going to bring this over to the next page here. So we have 0 over 0. So let's do L'Hopital's one more time. So I have the limit as x approaches 0 from the right side. Taking the derivative of the numerator, we're going to drop down that squared, decrease it by 1, take the derivative of the sine, which is cosine, and then the derivative of the far interior, the derivative of 8x, which is 8. And in the denominator, I'm going to use the product rule. So we'll have the first times the derivative of the second, which is negative sine 8x, times 8, using that chain rule, plus the second times the derivative of the first, which is times negative 8. All right, so I don't really need to clean this up too much because I'm just going to use a direct substitution here in a second. So I'm going to have 16 sine of 8x cosine of 8x over, let's see, negative 16x, positive 16x, because I have two negatives here. So positive 16x sine of 8x minus 8 cosine of 8x. All right, so let's try our direct substitution again. And we will have 16 sine of 0 cosine of 0 over 16 times 0 sine of 0 minus 8 cosine of 0. Sine of 0 is 0. Cosine of 0 is 1. So this entire numerator, I will have 16 times 0 times 1 over 16 times 0 minus 8 times 1, giving us 0 over negative 8, which means that we are finding e to the 0 power. And anything to the 0 power is 1.